Here we're going to use Venn diagrams to help us answer questions on probability. So first we're going to talk about some notation. This one, the first thing that this is, we'll say that each one of these, this is A, this is B, on all of them. I didn't label it, but let's go with it. So the very first thing, this U means universal set. So the universal set is everything. So it's everything inside this big box. The next one, this is A union B. And what this is saying is it's if you're in A, we want it, or if you're in B, we want you. So this ends up being something like that. Okay, so it's those two circles. The next one, so this one, I like to use the example, I would always have people stand up and say, stand up if you're a girl or wearing a blue shirt. Okay, and so then that would mean, so this is an or situation. So then I would have had all the girls would have stood up, and then any of the boys that were also wearing a blue shirt would have stood up. So we would have had boys and girls standing. We just wouldn't have had boys that aren't wearing a blue shirt standing. This one here is the intersection, and this one means this is an and situation. And so this, it has to be both in A and in B, and it becomes just this region right here. So then what I would have said is, okay, stand up if you're a girl and you're wearing a blue shirt. And so in that case, then I would have only had the girls stand that were wearing a blue shirt. And so it's a much smaller group of the room. Okay, this one is A union not B. So what I would say here, so we've got A, and then union not B. So everything not B is going to be all of this outside of B. So this ends up being, it's a union, so it's everything in A and everything not in B. It basically becomes everything but this little Pac-Man. Okay. The next one, it's A union B not. So it's the conjugate, or the opposite, that's maybe a better word, of A union B. So A union B looks like this right here. And now we just want everything else. So we're looking at everything that's not in either of those circles. So it's something like this. This is not A intersect B. So what I want to do here is I'm going to say it's not A, it's everything outside of A. But now it has to intersect with everything in B. So I only want the part of the green that's inside B also. So this becomes this little part right through here. The next one is not A union not B. So not A union not B gives me everything outside of A. And it gives me everything outside of B. And basically what happens is that it's everything except the intersection of the two of them. I'm having fun coloring. Something like that. So basically it's everything except this nice little piece there. This one is not A intersected not B, so it has to be both. It can't be in A and it can't be in B. So it's going to end up being this right here. Okay? Now some actual probability questions. It says, in a class of 25 students, 16 like boba and 14 like iced coffee. Okay, so we'll say one of them is boba, and one of them is iced coffee. And then it says one student doesn't like either drink, so that means there's one person out here who doesn't like either one, and 6 students like both. So in order to like both, they're in the intersection there. There were a total of 16 that liked boba, which my brain jumped to the answer. So this whole circle needs to include 16 people. Since 6 of them are here, that leaves 10 that like boba but don't like iced coffee. And then this next one, it says 14 liked iced coffee. Well, 6 of them also liked boba, which leaves 8 out here that only like iced coffee. Okay, so then the first question, what is the probability that the student likes boba tea? Well, there were 16 out of the 25, and so there we go. What is the probability that the student likes boba or iced coffee, but not both? So that what we're saying here is they like boba or they like iced coffee, but they can't like both of them. Well, there were 18 out of the total 25 that fit that, if you randomly select the student out of the class. What is the probability that the student likes iced coffee given the fact that he or she likes boba tea? What this one does is this changes our universal set. This changes the world that we live in. You could think of it that way. We are now only concerned about the people who like iced coffee. And then we're looking at the part here that also like boba. So this was a 6 out of 8. What's the probability the student likes iced coffee? Oh, you know what? I did this backwards. Given the fact that they like boba tea. So sorry. So the boba people, there were 10 out here. There were 6 over here that also liked the iced coffee. So given the fact that they like boba tea, so now we're only living inside the world of boba tea people, and 6 of those liked iced coffee, so it's 6 out of 16.